So we're gonna do three things in this lecture. So find what is increasing and decreasing, which you will see that's pretty simple. And also to find the local maximum. I told you every time they actually give you a graph, the question is a little bit easy or very simple actually. And then this is the part that's gonna be a little more tricky. This is technically from week 5, but we're gonna do this now and then we'll do all the rest on week 5. So let's start with a definition, which you will see you have a graph. It's a lot easier to do just from the graph. But the definition is the following. A function is increasing if f of x1 is less than f of x2. That actually looks pretty like theoretical, but it's pretty simple. Look, if you have the x and y axis, and then clearly x1 is less than x2 here, right, in the graph. And then remember, this is y1, this is y2. So let's say that f of x1 is here, and f of x2 is there, which means y1 is less than y2. So clearly, from here to here, the graph is increasing. That's all it means. Okay? So if you have the graph, it should be simple, but theoretically speaking, or in algebraically, this means increasing, and obviously the opposite will mean decreasing. Okay? This is also a topic that is going to be very useful, and you're going to do this in calculus a lot. So usually, this is how you're going to do the problem. Look, you're going to find first the part where this changes from a positive to negative, or it's called changing direction, and these are called the critical points. So like this is a critical point, and in calculus they are also called critical points, and this is another critical point. The only thing you have to be careful, you need to write the answer in a interval notation. I mean, you don't have to, but it will be easier, and I'll tell you what I mean right now. So clearly for this one, this is increasing here and here, right? That's what increasing is. So assuming that the graph ends here, so if the graph ends there, like if this is the end of the graph, and this is the end of the graph, then you can see that this is increasing from, this will be -3. So this is increasing from -3 to -2. Or the happy face means 1 to 3. Okay. If you want to write this in equations, this is how you will write it: -3 less than x less than -2, and this will be 1 less than x less than 3. So you can write it either way, but the interval notation is usually going to be the most common. And clearly, this is also decreasing from here to here. This is the part that is decreasing, which is where? It's from -2 to 1. Well, that's it. So you can see, if I ask you what is the function increasing or decreasing, this is fairly easy to do. Okay? Any questions on this? Okay. If this one would have an arrow here, though, if this one would have an arrow, then what will be the difference for the increasing? Well, instead of being 3, this will be infinity. That's it. If this one have an arrow in this side, then instead of being -3, this will be minus infinity. So that's the only thing you have to watch out for. All right, so now from here also, because going to the next part, you can see clearly that this is the maximum and this is the minimum. Now they're called local maximum and local minimum for a reason. Local means this is the maximum around all the points in here, and this is the minimum around all the points here, because clearly this value is bigger. This is it's going to be called in calculus absolute maximum, but right now we're only focusing on local maximum and local minimum, and you can have more than one. So like this is a local maximum, this is a local minimum. If the graph was doing this and it went down again, so this will be another maximum, another minimum, and so forth. You can have more than one. Okay. So we're going to be dealing with graphs the whole semester. So the first thing I'm going to keep adding to this is, well, right now all we care is whether this is increasing, what is decreasing, and what's the maximum, and what's the minimum. Okay? But there's a lot of other things we're going to do with the graphs later. All right, so let's move on to the next part, which has to do with increasing and decreasing. Sorry, with maximum and minimum. Again, this is the formula definition of what is a local maximum, what is a local minimum. This is literally the exact same graph we did before. You just have to be careful how you write this. So for example, here, what is the local maximum? And the local maximum, there are two ways to write this, okay? The maximum is always referring to the y value. So the local maximum is technically y equals to 8, which is right here. But that happens precisely when the value for x is -2. So therefore, depending on what they ask you, this is the answer or this is the answer. Okay? Now, the local minimum, the same thing, is going to refer to the y value. Well, what is the y value? Here is -4, so that's the minimum. And this happens when x is 1. So therefore, you can, if I ask you what is the maximum, you can say the maximum is y, but you have to emphasize is y equals to 8. Or you can say it's the point -2a. Either way is correct, or the same thing for the minimum. Okay? All right, so here, clearly, which one is the local maximum? Is this one. The local minimum is this one, okay? This is actually the graph for sine of x. Okay? I don't want to ask you any trick questions here, but this is just the graph. And from trigonometry, this one reaches the maximum when this is pi over 2, which is 1 point something. And the minimum when this is minus pi over 2, which is the same thing as 90 degrees or 270 degrees. Again, you don't need to know that. So from here, if I give you this question and I ask you what is the maximum, so you will say the local maximum, it will be y equals to what? 1. That's the local maximum. And it will happen when x is pi over 2. Obviously, if you don't know anything about trigonometry, you don't need to write as pi over 2. You will say this is 1.5 or 1.6, the approximation, and that will be good. And therefore, that will be the maximum. And the local minimum will be very similar. You will say this will happen when x is minus pi over 2. And the local minimum is -1, or you can just say y is -1. Either way is fine. So as you can see, this is pretty simple. Now, on this graph, if this one starts here and this one ends there, because this keeps going, but if that's the graph, where is this increasing and where is this decreasing? So this is increasing from here to here, and decreasing this part and this part, right? So if it has arrows, then it will keep going forever. But in this particular case, the increasing will be from minus pi over 2 to pi over 2, which could be minus 1.5 or whatever this is. And then this is decreasing from -2 to minus pi over 2, or from pi over 2 to 3. And as you can see, you have a graph to do the increasing, decreasing, max, min. It's very, very simple. So now this is the start of week 5, and we will finish this obviously next week. So here you have two equations, which is literally the same equation, okay? And some books call this one the standard form, other books call this the standard form. In this case and in this class, this one is going to be the standard form. Okay? Notice that both of them have the only one variable in common. Well, besides the x, what's the only thing they have in common? The a. Okay? But this is the same equation. This is u, and this is u and Halloween. It's still the same person. It looks different, but still the same. And when you do the graphs for this, there is two things that are going to happen here. So the graph either opens up, which I call that a happy face, or it goes down, which I call that a sad face. Okay? How do we know if it's going to go up or down? It all depends on the letter A. If A is positive, it goes up. If A is negative, it goes down. What we care right now is to figure out this equation, okay? That's what we're going to worry about. Now, these quadratic equations, the smallest value or the highest one has a name, and the name is called the vertex. So the vertex is always going to be either the highest or the lowest point. That's what the vertex is, okay? The reason why we're going to focus on this form is that this one makes finding the vertex pretty easily, or you have the vertex, you can create this equation pretty easily, okay? So the coordinates for the vertex are going to be h and k. So therefore, if you know h and k, you plug it in here. If you know this equation, you can get the graph. So if you know one, you know the other one, okay? So both of them, this is also h, k. So this is h, and this is k. They also have other stuff, and by other stuff, I mean they have a y-intercept, and they may have x-intercepts, but we'll talk about that in a little bit, okay? Right now, the main thing that we care is the vertex, okay? So now, if you look to this problem, which one is the vertex? What are the corners of the vertex? Is this one right here, which is 1, 2, right? So this is the vertex. Usually you put a B to emphasize as the vertex. This is the letter H, and this is the letter K. So then, if you want to figure out the equation, well, remember the equation in standard form is going to be this A, x minus h squared plus k. You already know the h and the k from here. The only thing you're gonna need to figure out is the a, and I'll show you how to do it right now. So if we plug this into the equation, this will be x minus 1 plus 2. Why minus 1? Because the value for h is 1, and the value for k is 2. Okay? So the only thing you still need to figure out is just the value for a. So to do that, you can use any point, any precise point. Notice this is a precise point, this is a precise point, and so forth. This one is going to be the easiest one all the time. This is the one that you should be using, which is the y-intercept. And you always have a y-intercept. So that's the easiest one to use. So remember, y-intercept means what? That the point is, so this is the point, x is 0 and y is 3. So that's the y-intercept. So if we plug that in here, remember this is x, this is y. That means, remember that y and f of x is the same thing. So this will be 3 equals to a 0 minus 1 squared plus 2. So 3 will be a times 1 plus 2. How do I get 1? Well, minus 1 squared is going to give you 1. And how do you solve for a? Subtract 2 from both sides. So 1 is equals to a. So that's the value for a. Remember that if a is positive, the graph has to go up, which is going up. So that tells you the answer is at least not wrong. So therefore, the equation in a standard form is going to be 1 times x minus 1 squared plus 2. So this is the equation in standard form. We already found the y-intercept. So the y-intercept was the point 0, 3. You can also just say y is equals to 3. And then what about this? Do you have any x-intercepts? You look to the graph, it should be obvious. Do you have any x-intercepts? No. So you don't have to have x-intercepts. And so in this case, there is none. But in the next problem, you will have some x-intercepts. So, is that okay? Any questions on this? Okay, so try this one. Find the equation. This is exactly the same thing I did right now. I'll give you 5 minutes and try this problem. Okay? Find the vertex, y-intercepts, x-intercepts, and then write it in a standard form. All right, so let's check. So the first thing you should focus on is always the vertex, which clearly is which point? 3 and then 4, right? So therefore this is H and this is K. By the way, here also this one is the y-intercept, which is the point, 0, -5. This case, you have x-intercepts. The first x-intercept is this one. This is the second x-intercept, okay? So therefore, you have the vertex, you have the x-intercepts, the y-intercepts, and we'll write it formally right now. So remember, the equation is going to be f of x, a x minus h squared plus k. So what do we have so far? F of x, it will be a times what? X minus 3 squared plus 4, right? So the only thing you need to figure out is what is the value for a. Well, remember I told you you can use the y-intercept. By the way, you can also use the x-intercepts at this point, but you should stick to the y-intercept. So that means 3, not 3, -5. So, because this is -5. So -5, so remember this point, you plug it in here. It should be a times what? 0 minus 3 squared plus 4. So then you have -5 equals to, how much is minus 3 squared? 9, and 9 times a will give you 9a plus 4, right? And then subtract what? 4. So this cancels, so you have minus 9 equals to 9a. So what's the value for a? -1, which the answer has to be negative. Why? Because the graph is going down. If you get a positive value for a, the answer is wrong. Okay? So therefore, the answer in a standard form is going to be f of x is -1 times x minus 3 squared plus 4. So this is the answer in standard form. We already say that the y-intercept was, you can just say y is equals to -5, but the complete form is 0, -5. And what about the x-intercepts? We say it was 1 and 5, right? But you cannot write 1 and 5. It's 1, 0, and 5, 0. Or you can say x equals to 1 and x equals to 5. But some people write 1, 5. This is wrong, okay? It's x equals to 1 or x equals to 5 or 1, 0, and 5, 0. All right, any questions on that? Now, in these problems, the difference between this and the previous ones is that in the previous problems, you were given the graph. You just had to look to the graph. Here, there is no graph. They only give you the equation, okay? So this is going to be more work. And in order to write in a standard form, you're going to need a strategy or a technique or a method called completing the square, which if you never seen it in your life, don't worry, you'll see it right now. But you're going to need completing the square to write it in a standard form. Remember, the goal is to write it in the form that looks like this. So you need to figure out the value for A, the value for H, and the value for K. But there is no graph, so therefore you can only just look to the graph and get the answer, okay? So this is how you're gonna do this. Like, you're gonna use something that is called completing the square. And I already told you this before, in math, the names are not original. So completing the square means you will get a perfect square, okay? And the method is pretty simple. You just have to pay attention. So here it is. To complete the square, the first thing you have to do is you only gonna need the first two. It doesn't mean you're not gonna use this one, still gonna use it, but you're gonna focus on these two first. And this is what I mean. So you say, well, this will be x squared plus 6x, and the 4, I wanna put it somewhere here, okay? Then, and this is very, very important, you have to make sure that the number in front of x squared is a 1. If it's not a 1, you have to make it a 1. So in this case, there is no issue. Why? Because this is clearly a 1. But you notice here, this is not a 1, okay? So if this is a 1, then you're good to go. This is what we're going to do. Focus on this value, whatever this is. Which value is this one in this case? 6. Whatever the value is, okay, whatever that is, you're going to divide by 2. And it's always divided by 2. So how much is 6 divided by 2? 3. And then whatever you get, you're going to square. How much is 3 squared? 9. Now, remember what I told you before, that in math, there's technically two things you do. You either add nothing to the equation to get back to what you have, or you multiply by 1 to get back what you have, okay? That's literally what you do in math. I know you don't believe it, but it's true, okay? So now here, we're gonna go with this. We're gonna add nothing, okay? And this is what I mean by nothing. Whatever value you get from the square, by the way, this value always has to be positive. Why? Even if this was negative, when you square it becomes a positive. Whatever you get there, you add here first. But I told you we're gonna go with this technique. So if you add a 9, the 9 was not there. So how do you get rid of 9? It was minus 9. Okay? So then, how much is this part? How much is 4 minus 5? Sorry, 4 minus 9. Negative 5. And this one, this part is going to be a perfect square. You can factor it, but it's actually no need to even factor at all. Look, what's the value you got when you divide by 2? When you divide by 2, what's the value that you got? 3. That's the value. You should check this. That's the value you're going to get here. So then, that's the equation. Okay? And now it's a perfect square. By the way, once you have this, which one is the vertex? It will be minus 3 and negative 5. Why minus 3? Because this is positive. Notice that you can write x plus 3 as x minus 3. So that's why this is minus 3. Okay? Is it okay? Any questions on that? Now, before we do the one with no, how do you say this? With a number that is not 1 in front, let me write this on the side. Let's do one more. So I'll give you a chance to check you know how to do that. Okay, so try this example. Look, let's say that now I ask you to put this in a standard form. So just try this for like 3 minutes. X squared plus 10x minus 7. Okay, so just try that. Okay, so let's check. So remember that to complete the square, you only focus first on the first 2. It doesn't mean you don't need a 7, okay? We focus on the first 2. And then what do you do with the 10? Divide by 2, which gives you what? 5. And then 5 squared is what? 25. So then you add 25 here. But since the 25 was not there, you had to subtract it also. that okay? Then the first part is going to become a perfect square. Whatever value you got when you divide by 2, that's the value that goes there all the time. And then how much is minus 7 minus 25? Minus 32. So therefore, what will be the vertex here? Negative 5 and minus 32. That's it. Okay? All right, so this is the process, and the trick is to add nothing, okay? The nothing part gets more tricky when the number in front is not a 1, okay? Because this only works if the number in front is a 1. So if it's not, what do you do? Well, here it is, look. So you only need the first two. So let me write that first again. And let me put the 4 in here. So what you're gonna do here, you're gonna factor the minus 3. It's what I mean by factor. You factor minus 3. And then this will be x squared. And what is the value that you need there to get 12? What is it? It's not 4, it's negative 4, okay? Because minus 3 times minus 4 is 12, okay? All right, so then this is the part, this is the part where it's tricky. We're gonna do the exact same thing we did, but we're gonna pretend that this is the problem, but that's not, okay? But we're gonna pretend this is the problem only. So then this will be like this one and the previous one. So which is the one you had to divide by 2 then, in this case? Negative 4 divided by 2 is what? Negative 2. And how much is negative 2 squared? 4, okay? So now this is the part where the confusion starts for some people. If you didn't have the 3 here, you technically are supposed to add 4 here. And what it will be the other step? You are supposed to subtract 4, right? That's what we did. But here you really didn't add 4. What you added is 4 times 3. How much is 4 times 3? Minus 12. So therefore you added minus 12, not 4. So how do you get rid of the minus 12? Is with 12. Right? Is that okay? Speak now, humans. Let me repeat this again. Like, when you divide by 2, the number you're supposed to add is 4. And you do add 4 here, but you didn't really add 4. You add 4 times 3, which is negative 12. And how do you get rid of negative 12 is with the number 12. And essentially, this is a easy way to remember. If this is negative, this one is going to be positive. If this was positive, this will be negative. Okay? Now, this is a perfect square, so it will be minus 3 x minus 2 squared for this part. And then how much is this? Well, that will give you 16. Is that okay? Does that make sense? So then again, look, this part becomes this, and this part becomes this. Now, once you have it in this form, what is the vertex? What is it? 2 and 16. So now, is this graph going up or going down? Down. Why? Because the number in front is negative. So remember, the value for A here is negative 3. So that means the graph is going down. The vertex is actually 4, 16, which means that this one has a maximum, and the maximum is 16. Okay? All right, any questions on that? Okay, so try this one. Let's say this is example number 5. And let's say f of x is equals to 1, 4 x squared plus 6x minus 10 or minus 13. Okay, try that for 5 minutes. All right, so same process. you only need the first two. Move the 13 somewhere here. And then you need to factor the 1, 4. So this should be x squared plus, what is the next number? 24. Why 24? Because 24 divided by 4 is 6. Okay? Now, an easy way to know that is this. Look, I told you, you multiply this times that, should give you this one, or 4 times 6 was 24. Okay? So then, what do you do with the 24? Divide by 2, which gives you 12. How much is 12 squared? 144, right? So then, this is the part you have to be careful. You're going to add here 144, but you really didn't add 144. How much did you add? 36. So then you add 36. Actually, subtract 36. Why? Because you add 36. This is positive, so that should be minus 36, right? So then this becomes 1/4 times what? X plus, what's the value you got when you divide by 2? 12. And how much is minus 36 minus 39? Sorry, minus 49. And that's it. So that's the equation in standard form. All right, so now is this one going up or is this one going down? Up, right? What is the vertex for this equation? It's technically minus 12, right? Minus 49. So let's say minus 49 is here. So this is the vertex. The graph is going to go up. So therefore, this will be a minimum. Okay? Now, there is a lot of different versions or a lot of different questions that can be asked from this equation by itself. Okay? You're going to have this on the test. This is what I mean. I can give you this and ask you to write this in a standard form. So if I ask you to write in standard form, then this is the solution. Okay? If I ask you what is the vertex, then you will have to do all the process anyways, and then from here the vertex is this. So that's another question I can ask you. I can also ask you what is the minimum value for this equation. So what's the minimum value for here? You have to go to this, you put it in a standard form, and the minimum value is what? Y equals to minus 49, which is related to the vertex. So as you can see, there's many things that can be asked just for this. Also, I could say, well, looking at this, is the equation going up or going down? And all you have to say, well, since A is positive, this one is going up. So there is a lot of different versions of the question, or a lot of different things that can be asked from this information. So, okay? But most of them are going to rely on you completing the square. The question you have on the quiz right now is related to this problem.